Hello, this is Scott Sanford.
Hi, Scott. Johanna.
How you doing today?
I'm all right.
Good.
Is there a way to just listen in online and not have the phone connection, or is that the only way there is?
That's the only way there is.
Okay.
Yeah, they apparently don't like the voice quality, so they don't recommend the voiceover.
Okay.
All right. I think we give people a couple more minutes and we'll get going here.
Good morning.
Good morning. Who we have?
This is Kate Field from Gateway.
Oh, how you doing?
Good. Real good. I'm enjoying these seminars.
Well, that's good.
And before we have our geothermal system we're trying to get going, so I'm going to copy all this information to our HVAC guys.
Okay.
And they may get a hold of you at some point.
Yeah, that'd be fine. Yeah, if they need to look at estimated energy use, I've got a model that can do that.
Yeah, I think they were looking at different options for underbench heating, and I was telling them, I don't think you need to reinvent the wheel, so.
Yeah, you can get off-the-shelf systems for that.
Right, but I don't know how it would manage with the system they're using, so. Pretty interesting, because I'm working with these people that I never thought I would have anything in common with, so.
All righty, let's see. I'll give it another minute or two here. I think there's a couple more people going to join.
Sure. And we've got thermal curtains on order, so.
Oh, that's good.
Yeah, we'll see. Hopefully we ordered the right ones.
Well, anything will help.
Oh, yeah. Definitely.
And you can, once you have the mechanical part of the system up, you can always change the curtain material later on.
Yeah.
Oh. Well, let's kind of get going here. And we'll see if some others join us. What we're going to try to do today is cover thermal curtains, and more to give you an idea of what the system involves and stuff. And I've got some slides here to give you some estimates of what the energy payback is.
Mm-hmm.
And then we're going to talk, at the end I've got some slides with some possible emerging technologies that may be coming on.
Cool.
So if everybody could, if you got a mute button, you can mute so that we keep background noise down. It would be appreciated.
Yeah, I can't find the mute button on my phone, though. I'm on my landline.
Okay, don't worry about it then.
Won't breathe.
All right, so we'll get going here. So first I can get this disclaimer is just the fact that if I talk about a product, I'm not endorsing it, or lack of talking about a product, not endorsing it. That's a university thing. We're supposed to be neutral. So that's in there, and it's been added to the previous handouts, just so you know. Anyway, we'll go on. So energy curtains. Oh, let me get rid of something here. I don't know if you can see my stuff popping up, but energy curtains, basically, are very simple. We're just trying to put another boundary layer to help keep the heat into a greenhouse and the cold out. So this simple diagram, basically shows we've got a curtain hanging up, which is a wavy black line. They can be just across the roof or the area, or they can be the roof and the sidewalls. They're usually not just the sidewalls because heat rises, so we're trying to keep it down. And then we have to support it somehow. So we can support it with a track, we can support it with cables, and I'm going to show you pictures of that. Now, one thing that's important for an energy curtain is that we seal the edges. If you're just doing shade curtains, and these curtain systems can be used for either, if you just use them for shade, you don't really care if the edges are sealed or not because you're just trying to block light. Well, for heat, we get natural buoyancy convection currents. And so we have to seal the edges. Now, we don't have to seal them pressure tight. We have to seal them against air movement. So we have a piece of cloth that lays over an edge. Doesn't have to be much more than that. And the other thing I'll point out is I'm going to use the word curtain. If you go out in terminology, the industry also uses the word screens. So the energy curtains or shade curtains or energy screens or shade screens would be what they use. Now, mechanically, the difference between shade curtains, at least an internal shade curtain, which is what we're going to talk about, or an energy curtain, a mechanical system is going to be the same whether you're using for energy or shade. The only difference is, as I said, is sealing the edges. We talked last time about heating. 80% of our heating is at night, and these shade curtains, basically a single wall glass or something has a U value of about 1.2. If we're of a double wall, we're about 0.7 to 0.4, and if we put a shade curtain, we can basically decrease that by about 40%. Basically, it adds another boundary layer. Uh-oh. We've got a fire alarm going on here. That's cute. Sorry about background noise. They can be used as shade curtains. And under a shade curtain, aluminized type shade curtain, they will reduce the air temperature about 10 degrees by blocking the sun. And their costs, installed costs, somewhere between $2 and $4 a square foot. A lot of it depends on how much stuff you have to go around. And we're going to look at some of that as we go through. Now, for a large greenhouse, an automated curtain system can be advantageous. But for a small greenhouse, it can be manually opened system to lower costs and basically it can be just a cloth that you pull over the crops. Let's see. So the potential energy savings. So I've got an example here. It's about a half-acre greenhouse, just a little under a half-acre. We got a double poly film. We're using propane heating. We're spring bedding plants. Our expected cost is about $20,000 to $21,000 a year for energy costs with that size greenhouse. If we put a thermal curtain in, it's going to reduce our cost by about $7,100. And that's using a shade cloth. It's a 42 or 45% sunblock or 55% light transmission, which will give us about 52% energy savings when it's closed. And that's assuming just the roof is covered. So about a 35% overall savings. If we look at a little freestanding greenhouse, same kind of scenario. We'd use about $3,100 in fuel costs. We could reduce that by about $1,000 using covering 90% of the roof area and 50% of the gable ends. So this is not going to be a hoop-type structure. It's going to be something with some sidewalls on it. About 32% energy savings. So I wanted to give you those up front so you can see it can be a fairly substantial savings by using energy curtain. So the types of curtains. Basically, we need to pull something across the roof area. So it works best when you have a high sidewall greenhouse, but As I said, it can be done in other types of greenhouses. I'm going to show you one toward the end. So this we got here is this one's a gutter to gutter, so the curtain system is going to move across, back and forth, and it can be. Typically, they'll have the cloth will run the length of the greenhouse or some portion of the greenhouse, and it'll go back and forth. The other way to do it is actually they usually use small sections, but this leading edge would open up and come to the next truss. And that's the more common way it's done today as far as commercial systems. The biggest thing that this does, besides putting a boundary layer, it reduces the volume of the greenhouse we have to heat because it's blocking off, it's making an attic space in the greenhouse. And this is typically the lowest cost type curtain because it's just a straight line. And you're going to see some of the other ones, we're going to try to go up and around stuff. So here's one of the issues with greenhouses. Growers like to hang stuff from the rafters or ceiling or whatever, whether this is set up for hanging baskets, but that gets in the way because you can't easily put a curtain in a situation like that. So some of the installation issues are basically the things hanging from the ceiling: plants, irrigation pipes, lighting, heating, poly tubes, lots of things in the way, and that adds to the cost. The other issue is ventilation. If we have gable or roof vents, that can be an issue for summer ventilation if we're going to use this for the summer as well as the winter. It can be an issue if you need to vent during a winter day and you have it pulled as well. But there are ways around that. So here's the other way you can do it. If you don't want to move the stuff, you can have one that follows, basically starts over here on the edge and comes up and across the top and back down. Basically, so you can have stuff hanging in here and you don't have to move it. The other is what we call a slope. This has the advantage, it has the same advantages as a flat slope, but it also minimizes the amount of trapped air. Some greenhouses it may be a little easier to put in. Now these are all usually set up in sections, and the next is going to be a picture of one. So here is a flat slope. We've got it going up, across the top, and a flat, and then it comes back down the other side, and it's in sections. You have a section between each truss. So here's a truss back here. Here's the one here, and this is this curtain. This is actually the leading edge here, and that's the leading edge there. So this is going to move until it comes in contact with a seal that's on the back side here. Let me change colors so it's easier to see. So I think that should be red now. Yeah, so there we go. So it's going to move across. So the advantages you can see obviously in this one. I got hanging baskets. I got a poly tube air system, and I didn't have to move any of that stuff. And when they're open, you can see it's very open, and the only thing you have is the thickness of what it takes to fold the curtain up is the only thing that's in the way. Now you do have some support lines and stuff running in here, but as far as blocking light, it's quite minimized. So what kind of materials can we use for shade curtains? So we're going to talk about the types of materials. The first thing we can use a piece of polyethylene film. And they're basically broken into three classes here. We got non-porous, would be a waterproof film. We have semi-porous, and we'll talk about that. And we have porous. This would be similar to some of the shade cloth materials that are currently used. Aluminate would be one, or just a black shade cloth. They will help reduce heat loss to some extent, but fairly low. The biggest problem, with non-porous materials, they do have high heat retention values because they don't let much air go through, but they're impervious to water. And the systems, if you know, we go back a couple of slides here, you can see this is a fairly thin material. It's held up with, these are actually monofilament lines here. Those are little, basically heavy-duty fish line, and they're not going to support a lot of weight. So what happens in some of the early ones, they found it real quick, is that these things will fail if water collects on top. So we're going to get condensation dripping off the roof. If it puddles too much in one spot, it could take down the system. So one of the things is they've come up with is non-porous or semi-porous materials. If you think of a blue tarp you can go to the hardware store and buy, it's a woven fabric. It's the same thing as that, but they don't waterproof it. So it's just a weave. And that allows moisture to migrate through, but it really doesn't have, it has very small openings, if any, because it's a tight weave. And it still has, so it won't let much air through, but it still has high heat retention values, which is the whole reason we're doing it. One of the things with the types of curtains, the more shade it supplies, so the higher the shade value, the higher heat retention value. And we're going to, next slide is a picture of some of the materials that are used. Life of a curtain is 8 to 12 years. It's going to depend on maintenance. These things are going to rub as you open and close them, and you know, maintaining the edges and stuff. It's going to be important to the life of, to get a good life out of them. So here's an example of some of the materials. I don't know if this first one, well, you can probably see we've got aluminum strips, so it's a weave both ways. So we can use something. This first one over here is basically just a piece of woven material. It's just a polyethylene or whatever the material they're using. So it lets lots of light through, but it will retain some heat. Next, this one's approximately what I'd recommend if you're wanting to use it for shading. So you can see you have basically an alternating strip of aluminum strip, which is going to reflect the heat in and out, and allow to provide heat retention of about 52%. So we go all the way down to this one over here is a full sunblock, basically 99.9 sunblock. That will provide about 70% heat reduction or heat loss reduction for the area it covers. Those fabrics they're very thin and flexible. So here's an example of the light transmission effect versus the energy savings. So you can see this trend as the light transmission goes down, the amount of energy I save goes up. So here I've got semi-porous and I've got porous. The porous could be the same material here, but they leave out this. There's a clear strip in between these aluminums. They'll leave out that clear strip, so it's porous. But when they do that, you lose the ability to retain the heat because you get convection heat loss. So you can see you end up with fairly low values. Aluminum, that's a woven aluminum material. So here's a 50% shade and a 70% shade. You know, 7% shade, you'll get actually quite a bit of reflective value out of that, reflecting the long-wave radiation back into the greenhouse. But it's kind of a bulky material and probably wouldn't fold up very well. But again, it could be used as a curtain material. So when we're talking about this, we've got shading factors. So what do I use? One of the things is that during the summer, if I'm going to use this for shading as well, during the summer we get about 10,000 foot candles during a midsummer day. Plants can only use about 45,000 foot candles. So if I do the math, and we're going to lose some through the glazing. So I've chosen for my example here a double poly, 80%. So I've got my 10,000 foot candles times my 80%, and I'm using a 55% light transmission value. Now I do that, I get 4,400 right in the middle of this range. And I'm going to get 52% energy savings. So that's what I would generally recommend if you wanted to use it for shading and heat retention. Now, if you're only after heat retention, you might as well use the full sunblock. Some other issues with these is some of these materials are flammable. So if they're going into a public building, you need to make sure which ones you choose. And they do make some that are flame retardant or will pass the requirement for public buildings. When we're mechanically trying to get these, fold these up or move them out of the way, they can be roll up, bunch up, or like a pleated fold. The example we showed before was a bunching. I'm going to show you an example at the end of this slideshow of one that's a suspended curtain that folds up. And then the other issue is if we want to have day-length control or blackout, that may also influence, and basically that's full shade. So how do we support these things? They can be supported in two main ways. One is with cables. They slide on cables, or in this, for a sliding curtain, it's usually on monofilament lines, and you can see them right here. They're about every 12 to 16 inches across this greenhouse, and the curtain material just lays on top. The other is suspended on cables, and I'm going to show you that toward the end. And basically these lines, in this particular greenhouse, we had to put a extra purlin in here. This is the one that came with the greenhouse here. And then we had to actually put an extra purlin in here. And then the support lines were tied to that, basically to get them at the right level. So that gives you an example of that. Opening devices, they can be motorized, which if you buy a commercial one, that's usually what they supply is a motor to open it. They can be hand cranked. And I've got an example of one we did for a local greenhouse. It was hand cranked. Disadvantage, you got to be there to open and close it. But it does have some lower costs. The other could be just a pull curtain where you actually have it so you just grab the leading edge pipe and just pull it across the greenhouse. So that's, we can, depending on available labor and timing, that can be done too. So here's an example of a motorized one, and some of these pictures get dark. It's surprising how hard it is to get good pictures in a greenhouse because of the light differential. But down here in the lower right corner, here's my motor and drive unit. We've got a gear drive unit, and it's driving some shafts. So we've got a shaft going out each side of this, and in this particular case, this was like an 8-bay greenhouse, and there's one motor drive system for it. And you can see up here, the motor sits up here, and this is that flat slope system. This shaft comes down, and then it comes to a jack shaft underneath the gutter, and then a shaft up to the next greenhouse. So quite a beefy mechanical system here with universal joints and bearings and stuff that need to be maintained. The cable for this one actually wraps around. You can see it right here. Actually, let me get rid of some of this. It wraps around the pipe for the drive shaft right there, and it basically feeds on in one direction and feeds off in the other direction. So it's just like a winch, essentially the way it works. Here is another type. This is called a push rod type. Again, these are a little hard to see, but here's my drive unit. It's over here. My drive unit is over here. I've got this is my drive shaft coming out here. There's a rack and pinion right here that pushes a push rod, So this is actually the rack rod. If you look carefully, you can see the little teeth on that lower edge. So there's a gear over here that drives that rack, and that pushes a rod that runs the full length of the greenhouse back and forth. Then everywhere we have a curtain section, we clamp on to that push rod. So here's the push rod coming through. We've got some support rollers here, and that clamps onto the leading edge of that curtain to open and close it. We're going to talk about leading edge in a minute. This is actually the leading edge seal for this greenhouse. It's just actually a little flap of the curtain would come in underneath this little plate here, and there's a flap that just lays on the leading edge to actually seal that. Here's one we did for a little greenhouse. It's a 30 by 96 greenhouse. We were able to put it across about 18 or 23 feet of the roof section. So it comes across the middle here, and I've got actually a picture later on to show. But here's my drive shaft, runs the length of the greenhouse. We have a cable that goes. This is actually a side to side, so the curtain opens across the side of the greenhouse. Here's my cable running to and from a pulley. We've got a pulley. Don't use plastic pulleys. We did, and we've replaced them all because they wear out too quick. Less than a year. And then this just wraps around the pipe. So this actually down here in the lower picture, this is the crank handle. Here, much like if you're familiar with a dairy barn where they have roll-up sidewalls, it's just basically a pipe with a handle on the end, and you crank it, and it moves this whole shaft, rotates up here. And when you do that, it moves the curtain across. The curtain is clamped through this cable. One of the things, let me go back to this picture here. One of the things that happens is this wrap of cable, this is going to translate as you open and close the curtain. This is going to move back and forth, and I put an arrow here. So in our case, where I think we're running 23 feet across, this actually will run about probably 8 inches either way from the center line. And what that does is it actually changes the angle that the cable is coming into these pulleys, but also changes the tension on these lines. So there's a limit to how far we can do these curtains. You probably wouldn't want to go the length of a greenhouse, but you can go side to side. Here's a little different cable drive system. This is what I call spool on, spool off. Apologize if the picture is dark, but it's the only one that came out. But we've got this. This is the drive shaft here. It runs. We've got the cable wrapped around it. And we've got enough cable wrapped on. You can see this side here has quite a bit of cable wrapped on it, and there's very little left on this side here, which you can see there's an anchor bolt right there. So this side is spooling off. So let me get rid of the lines here. The cable over here is spooling off as this is turning, and this one's filling up. So that's how we're moving the curtain back and forth. Now, one of the advantages of this is the distance between these two cables is always going to be the same. So the tension shouldn't change as much as on the previous one. On the previous one, the cable is clamped elsewhere. It's basically clamped at the clamp that holds it to the curtain. This one, the end of the cable is actually clamped. There's right here because there's a bolt. So it's a loop after you go off of this. One thing, the larger the diameter of this pipe, the less translation distance, or the amount of cable you'll need for a certain distance, or the amount that this will have to walk across here. So that can be an advantage. Here's some examples of attachments. This is our grower-made curtain. Over here, we basically made a little clamp to clamp around the cable, and then it has an offset with a clamp to the leading edge. The leading edge has a pipe in it. You can see this is just a piece of poly we were using for experimenting to see how this worked, but this aluminum tube that's in this lower center picture is actually sits right in here on this leading edge, and that's what this clamps to. Almost every curtain is going to have a pipe in that leading edge. So this one in the upper corner, that's a commercial curtain. And you see it's a nice little clamp that clamps onto the cable. Here's a different kind. Here, this one down in the lower right, that's actually more of a gathering thing. We have a curtain that slides on top of the cable, so you can see how this curtain material bunches up. So the industry has these little gathering piece of plastic. They just clamp onto that pipe and gather that material as it pushes back or as you open the curtain. This one over here would do the same thing. You just, in this case, you have a cable top and bottom, so the curtain can't go beyond the cables. But that's how we attach to the curtain to open and close it. Now I talked about sealing the edges. There's a couple different ways you can do this, and there's no one right way. Most of the industry is using, basically, you form a gutter. You can see in this picture we've got a closed curtain over here, which is actually a suspended curtain, and over here, or no, that's a sliding curtain, I'm sorry. And this one over here is a suspended curtain. But this is actually in the middle of the greenhouse. We took a piece of monofilament line and ran across the greenhouse. We took a piece of well, here's a better picture of it. So we've got a support cable here, one here, and we took a piece of almost clear material and draped it around, came across the top, and then we put a staple in it. This whole system is basically stapled together. Use stainless steel staples. So this goes around and clamps, and then we've got this position so that this edge on here lays across and hopefully contacts this edge to reduce the possibility of airflow. So here's a picture from underneath. So we've got on a curtain we're going to have one fixed side, and this lower right or left picture shows the fixed edge, where we've actually clamped or fastened the curtain to the side of the greenhouse. On the other three edges, we've got two edges where we have a gutter, a side seal, and we're going to have a leading edge seal. And here in the bottom picture, you can see again, this is sliding with the support monofilament line holding that curtain up. Here's a little different design. This one actually has a piece of fabric lays down, but in this edge, they've got it weighted. It's like a sandbag type thing, just a little bit of a weight in that, or tube with some weight in it. So when this curtain, this is the leading edge of the curtain, when it pulls, it's a little dark over here, but this actually just lays on top of the curtain, that seal. So you can see right there, the seal is going to lay on top of the curtain to provide the seal. So, even if you get a little sag in the curtain, this should have enough, especially with the weight, to dip down and seal. So just another way to seal an edge. The other thing is the leading edge. That can be, well, okay, I'm going to talk about that in a minute. Okay, so here's a picture of purlins I've added. And you can see the loops off the monofilament line. Basically, these are just tied with a couple half hitches. These monofilament lines will stretch. You're going to have to retighten them probably after the first year or so. But they just tie on there. You can also use a sledge-type clamp on one side if you'd like. But you really need to, with a monofilament anyway, because they stretch, you need to be able to retighten them in some fashion. So we've added these support purlins for both the support lines and sometimes the drive cables. These lines are about 12 to 16 inches apart. Sometimes you want them closer because these curtains, they tend to sag a lot. And we ended up, we actually have, it's hard to see, but there's a drive cable coming right in here. And we actually ended up having to put a couple extra support lines right over that because it was falling down and catching the cable. If we do a suspended curtain, we can have much larger spacing, and this would be an example of how a suspended curtain is supported, where you've got clips on the top, and it runs along a wire or a cable. And in this case, if you can see the white strip, they actually stitch a reinforcement strip to that, and these little clips hook into that to add support to that. Ceiling edges, I talked about the side. Here's an example. On this gutter-connected greenhouse, they actually don't have any seals underneath the gutters. They bring this material down. It's all one piece, and it goes up. And basically, it's, I think in this particular greenhouse, it went for 6 bays, all one piece. Basically, it was whatever you needed for the width, plus I think the truss spacing was like 10 feet. So it's like maybe 11 foot wide and could be a couple 100 feet long. So you just, when you go to put these in, you kind of drape them through and run them the best you can to get them in position. And then when you're happy with where they're at, then you clamp them in. So under the gutters, there's actually no seal. It's just on the end walls. So here's another example of a gutter where the curtain material is just hanging in the gutter here. Occasionally we do have to do a little maintenance on these where you get an end that falls out, especially on the leading edge, can be an issue. And that takes sometimes a little maneuvering to try to figure out how to keep that in there. But can be an issue, but not always. Okay. Corners. Corners can be a real, you have to be really creative in the corners. In this case, here's my leading edge. This is where I'm going to make a seal for my leading edge. And then this is my gutter. And so we have to block the end off, but we got to make it so when that curtain comes in here, we got that floppy edge. We want to make a seal there. We're going to have a seal along the stop edge, but we need to make a seal down here. So that can be kind of creative. Here you can see little staples. We've stapled this together, so we just put a piece in the end and stapled it in, and had to do a little experimenting. But the biggest thing is you want to make sure that you get a seal as best you can. These things aren't airtight, but you're trying to get as best you can. This shows in this particular greenhouse what we did for a leading edge. It's a pretty good picture. We've got a sliding curtain, so it's going to come on top of this wire here, or this line, and that leading edge is going to butt up against this piece of fabric that drops down here, and this is made so that it'll give, so we can push it. And I think, okay, we'll get back to that in a second. The other issue you run into in some greenhouses, the end walls will have fans in it, will have louvers and heaters. In some cases, we can't move those items. So we may not be able to get all the way to the end of the greenhouse. So one thing, for instance, this greenhouse, the end wall is basically right over here. And we didn't cover that last section between the truss. What we did is put a piece of fabric up basically to seal the attic space. So here's my gutter here for the curtain. My curtain's actually closed in this picture. And we just block this area off to seal off the attic space so that we had as much of the greenhouse closed as we could without incurring a lot of extra expense. Heaters, you want, actually you can just make the top of the heater here. You want heaters so they're blowing below that curtain material. You don't want them blowing up in this area. So we actually, in this case, we actually lowered the heaters to get them so they're blowing underneath the curtain when it was closed. The ceiling edge, this shows a commercial greenhouse. I don't know if you can just make it. There's a, right there. There's a rubber flap. So what happens is the leading edge pipe comes up and will tuck under that rubber flap to make the seal. So the leading edge for the other curtain's over here. And that's going to go down in this picture down to here to hit with that seal. And you can see in this case they actually have grommets through this extrusion to space out and support the support wires coming through that. So here's a picture back to our grower-made system. We've got this curtain material hanging down here, and the leading edge butts up against it to make a seal. And you can see down here. So here's a pictorial of what we're trying to do. We're trying to butt up against it. We've got this, so it just hangs there. If it gets too tight, this bottom pipe comes up against the line here and stops our progress. But it'll have some give to it to allow for the fact that this leading edge is not always straight. It's just sometimes really tough to get them straight because sometimes the greenhouses aren't straight to begin with. Controllers. How do we open and close this? We've talked about doing it manually. The other thing is we can have a controller. This is an example of a standalone controller, and this can be set up to open the curtain based on, or close the curtain based on light level. They can be set for opening and closing at a certain time. They can open it in stages or close it in stages. And we'll talk about the management of it because that's important. These are going to have cold air above them when you open them in the morning, and we've got to look at how we do that. The controllers can also be part of a fully automated climate system for a whole greenhouse. Management or maintenance, we've got seals I've talked about to maintain. If we don't maintain those, we won't maintain the energy savings. And especially, if we get any holes or gaps, we can get cold air coming down and chilling the plants underneath the leak. So it's important we keep up with that. But the other thing I just alluded to is opening. We've got cold air above that curtain in the morning. We want to get it warmed up a little bit, so we've got to figure out how we're going to do that so we don't harm plants any more than possible. So one way is to allow the air above the curtain to warm up, let the sun come up, warm it up. When it gets up to a certain temperature, then open the curtain. The other thing we can do is open in stages. So we might open it, a few inches and let some of the air come down and mix and warm it up, and then open it up a little further. There's a greenhouse in northern Wisconsin that some of these pictures came from, and he told me that when the curtain opens, they send everybody off to break because very often there's basically ice. The condensation that was on the top of the curtain is turned to ice, and if they leave everybody out there, they get a shower. So they just send everybody on break for a while and let it all drip off, and then they come back and resume work. Now, if we have snow, we need heat to melt the snow off. So, and if we get snowfall, we need to open that to get the snow to melt off for at least a period of time. Cost, I already told you, it was about $2 to $4 a square foot. It's going to vary with size. A smaller greenhouse is going to be more expensive than a larger one. The type of material that we're using for our screen material will have an effect on it, and the number of obstructions. The number of obstructions will, depend on the type of curtain we can use, but also the installation time. I can tell you from experience, if the benches are full of plants and stuff and you have to move them around, it's going to take 2 or 3 times longer than if the greenhouse is empty and everything's out of the way and you can just go in there and do it. With a gutter-connected greenhouse, a lot of times they try to use high lifts to do this with. So if you don't have a path where the high lift can run down the greenhouse, it's going to take a lot longer to get that installed. So the best thing is to have a greenhouse with no benches in it, open, or at least move to one side so you can get in there and get the structure up as quick as possible. It is going to be easiest to put in a gutter-connected greenhouse or a A-frame type, but you can do it in a hoop house type too. You just have to be a little more creative. And it may be a case where you're going to have to look at the heights above the floor. In some cases, some of these greenhouses, you may not have the height to put one in, which can be a challenge. So here's one of the project houses that I've shown a lot of pictures from already. This was a typical Gothic style or semi-Gothic style. Had about 3-foot sidewalls. Lots of stuff. We got some plant hangers down the middle here. We got some fans hanging. We got lights. Lots of stuff in the way of putting a curtain system in. Our plan was this is an east-west facing greenhouse. So our plan was we were going to take the curtain and run it from the north side across the south side. Is the way we installed this. The other thing for this particular project is that we bought all off-the-shelf items, and if we had to make something, farmers are creative. We had to be able to make it in a farm shop. So you couldn't have something that needed to be lathed or whatever, but if you could have something that needed a drill press. So what we ended up doing to hold all the stuff that the grower wanted to keep in there, we ended up putting a substructure in. So that's this actually. So it was the same size square tubing that this is the bottom cord up here of the truss system, and this is about a 12-inch gap here that we needed to run the curtain in. Basically, you need somewhere between 8 and 12 inches, depending on the type of curtain, of clear vertical or horizontal space, or vertical space and horizontal to run a curtain in. So that's how we accomplished it. We reattached all the lights, and this is electrical, or all the electrical runs to that, and then mount our curtain system in between that space. So here's an example. This is the suspended side. In this particular greenhouse, one side was sliding and one side was suspended. It turned out it was going to be it's a hand crank open system. It was too much to have the whole greenhouse open at once, so it's actually split into 2 halves, which does have some advantage if they want to do shading. But you can just see the edges of this. This is a pleated curtain, so it comes already set up to fold in an accordion-type shape when it folds up, and this is showing it's halfway open. This is the leading edge up here. It would go across, and it's hard to see the drive cables. I don't see any there, but drive cables are actually above the curtain in this case, whereas in the sliding curtain, they were below. So in this greenhouse, we did have a quote from a commercial curtain system. It was about $7,500 for materials. We did what I've just shown you for just about 60% of the roof. We did for about $3,500, and we're estimating we could do some roll-up sidewalls for about another $1,000 a side to actually increase the energy efficiency of that greenhouse some more. So just to give you an idea of what the costs might be. So this is $5,500. I think that's in that $3 a square foot type range. Suppliers of these curtains, there's 3 companies that I'm aware of that just sell curtain systems. VRE, they're out of Canada. Wadsworth, that they actually sell other types of control systems besides curtains, but they have a curtain system. Then Gentech does curtain systems. As far as the curtain materials, Swenson is the most popular one. They're out of Sweden. That's the materials that I've shown you are there, but then there's also a product by TGU that is similar material, a little different style fabric, but again, will work fine. And then I should point out that most of the greenhouse companies that make greenhouses, many of them either use one of these companies for their system or have their own system that fits their particular greenhouse. So one thing, if somebody is going to buy a new greenhouse, you want to look at the frame of the greenhouse that, even though you may not be able to put the curtain system in now, make sure it's got space to do it. Some of these new gutter-connected greenhouses are already set up for space to put that curtain system in. Now what I want to show you is a couple new technologies that are out there. For years, especially with double poly films, greenhouses, engineers have tried to come up with ways to increase the energy efficiency. Back in the 70s and 80s, they were trying to take foam pellets and blow into that cavity and then suck them out during the day. The problem they had is they couldn't get them to come out sometimes. Either condensation wouldn't let them come out, or the other problem they'd have is static electricity would hold them there, and they couldn't get them to come out. So that kind of system never panned out. Well, actually, within the last 5 years, there's a couple companies that have come up with foam systems where they actually make soap suds type foam and fill that cavity. Claim is about 50% energy savings, so it's pretty similar to energy curtains. Their claim is they actually have a higher heat retention value. I have to go by their numbers, but they're claiming 50% energy savings. The foam will dissipate itself. So you're making foam bubbles, it's going to break down. So what you end up having to do is to, if you're going to have foam fill that void during the night, you actually have to continuously kind of put a little foam in there to maintain that cavity being full of foam. And then when the sun comes up, we simply just wash them away. So this website that I've got here, you can go to there, and they have a little illustration and some more information on it. The systems, at least what I've seen, is quite a bit more than an energy curtain in cost. But it's brand new on the market, so as time goes on, that may catch on and get better. One of my concerns with this system is that we could have condensation build up during the day between the double poly because it's wet already. So I'm not sure how that's going to affect sunlight, but I haven't seen any data on that. So here's a pictorial of a system. Here you can see over here we've got, we've basically foamed the cavity. We've got some way to collect the foam or the water. Up on top we have some type of device to create the foam. This one came off a site where they're actually talking about dripping water down here through the day to warm it up to provide heat. I'm not sure that's going to work for a northern climate like we have because we need all the light we can get during the cold weather. But that's somebody's idea of a system. So here's kind of what it looks like from the inside. I think my guess is this is spraying foam off. What I'm going to do is I'm going to show you a little short video. Hopefully I still got it up here. Everybody see this?
Mm-hmm.
Okay. Just to show you foam, and I think the noise, if you run this yourself and hear the noise, I think it appears that it's pouring rain when they're making this video, which is kind of humorous. But you can see it's just filling that void with foam. So this is one way to do. You're basically keeping the air in that void from moving, which reduces the heat loss. So I'm going to stop that and we'll go back to the other. All right. So that gives you an idea of I'll call it an emerging technology. There's a company that has looks like a half dozen or so installed in Canada. The one company's website I gave you, that's where they're out of. So we'll have to keep it in mind and watch it. Next thing I want to talk to you about is grants. How do we help growers or maybe your greenhouse pay for this kind of stuff? And one of the best sites to find information is this database of state incentives for renewable and efficiency, Desire. If you go to this website, you're gonna find they're gonna have a map of the U.S. and you can click on your state and find out what programs are for your state. There's a flag, American flag there, and you can click on that. It'll give you the federal grants, and it breaks them down by energy, renewable energy and energy efficiency, by utility, by residential, business, renewables. So you can sort through to try to figure out what you're after. The other for Wisconsin. So if you're in a state besides Wisconsin, you'll have to look at that site and figure it out. But for Wisconsin, we have something called Focus on Energy program, which has been around since 2000, that provides energy efficiency grants for renewable energy and energy efficiency. It will cover up to 25% of the cost of a project, and it's based on, the grants are based on the projected first-year energy savings. Utility has to be participating, but most are these days. There's still a few co-ops out there that don't participate, but they have public benefit dollars that they use. They can dole out for projects themselves. Now, this Focus on Energy program only deals with electric and natural gas. It doesn't look at propane or heating oil because those aren't regulated utilities. The agricultural program, which is what greenhouses would fall under, they provide free energy audits, and the people that are involved in that don't sell equipment, so they're pretty unbiased. Actually, I provide quite a bit of the training for those folks, and they have a tool that will estimate your energy savings, energy usage, and energy savings. That'll ought to give you a pretty good idea of what you can save on a particular project. So that's one grant program. The other is from the Federal Farm Bill. It was initially part of the 2002 Farm Bill, and then it was upgraded, or it was extended in the 2008 and upgraded. This does energy efficiency, renewable energy projects. Can also do feasibility studies. That's actually new, I think, this year. It'll cover up to 25% of the cost of a project. So, example, if you have a $10,000 project, you could get a $2,500 grant max. They have minimum, maximum grants depending on whether it's renewable energy or energy efficiency. So anywhere from $2,500 to $500,000 for renewable energy, and $1,500 to $250,000 for energy efficiency. It can't be used for transportation or field equipment, and it is a competitive bid process. So you decide what you want to bid or how much money you're asking, and they rank it based on how much energy you're saving, how much money you're asking for, et cetera, et cetera. So they will do that, and the other part of the project or program is guaranteed loans. So you can get a guaranteed loan for 75 to 85% of the cost of the project. 85% is less than $600,000 projects. They have a minimum and maximum loan, so 5,000 to 25 million. They accept applications continuously and make awards quarterly. Now that was last year. We'll have to wait. The RFP for this hasn't come out yet, or the notification of funding. But this year they're supposed to have over $100 million. In the past, it's been about $23 million split between these programs. So here's a couple websites down here. You can go find more information about it. Now, one of the nice things is you can use both a REAP grant and in Wisconsin, our Focus Energy grant together. So you can essentially, theoretically, you could cover half the cost of a project. For greenhouses, a thermal curtain or a high-efficiency heating system that we've talked about are two excellent projects, and we've got two of them that have been funded in the past year in the state. So those would be some very good projects that have excellent energy savings. There would be good projects to go for. Now, it's a federal program. There's lots of paperwork. So if you can get through the paperwork, it should pay dividends. But anyway, that's the end of what I was going to cover today. Does anybody have any questions?
No.
Well, anybody offline have the question? All right. Well, our next webinar is going to be next Tuesday, and that time we're going to cover bioenergy, so use of wood basically for heating greenhouse and the systems, and what you have to look for. And then the following Tuesday, on the 26th of January, will be Eric Runkle from Michigan State talking about energy savings using production methods. So we're going to talk about diff and lighting for the most part. So if there's no questions, we'll call it a day. And in a day or two, I'm going to send you out or maybe I'll actually do it today, send you out an evaluation form. So I appreciate your time.
Thanks, Scott.
Yep.
Thanks, Scott.
Thanks a lot, Scott. Bye.